Welcome to the DIY Honda Garage channel. This presentation focuses on the DTC codes P0455 and P0456, which indicate a problem within the EVAP system of the Honda CRV models from 2017 to 2022. DTC P0455 refers to a large leak detected in the evaporative emission control system, while DTC P0456 indicates a very small leak detected. EVAP, or Evaporative Emission Control System, is an essential component that captures and stores fuel vapors from the fuel tank and allows for their controlled release into the engine, preventing them from being released into the atmosphere. It's crucial to identify and resolve these issues promptly, as they can lead to more severe emissions and fuel efficiency problems. Throughout this guide, we'll examine the components affected, possible causes, symptoms of the issue, and the specific troubleshooting steps necessary for these DTCs. The EVAP system in the Honda CRV captures fuel vapors from the fuel tank, preventing them from escaping into the atmosphere. The affected components include the EVAP canister purge valve, EVAP canister vent shut valve, and the fuel tank vapor recirculation tube. The EVAP canister stores fuel vapors until they can be purged into the engine for combustion, aiding in fuel efficiency and emissions control. The location of the EVAP system components is primarily in the engine compartment and around the fuel tank, making accessibility essential for effective troubleshooting. Understanding the roles and locations of these components makes it easier to diagnose and rectify issues that might lead to DTC P0455 and P0456. Several factors can lead to the triggering of DTC P0455 and P0456. A blockage in the EVAP canister vent line can create excessive pressure or prevent vapor flow, resulting in a detected leak. A faulty purge valve can also affect the system's ability to manage fuel vapors effectively. If it doesn't open or close correctly, it may either fail to purge vapors from the canister or allow them to escape. Additionally, any damage to the fuel tank or its associated components, like the vapor recirculation tube, could create leaks that result in these DTCs. Understanding these potential causes is critical for narrowing down the diagnostics and efficiently addressing any leaks within the EVAP system. Drivers may notice several symptoms when experiencing DTC P0455 or P0456. The most immediate indicator is often the activation of the check engine light on the dashboard, signaling that the vehicle's onboard diagnostics have detected an issue. Additionally, a noticeable fuel odor near the vehicle might suggest fuel vapor leakage, indicating a malfunction in the EVAP system. Lastly, inconsistent fuel economy can occur. If fuel vapors are improperly handled, it can lead to inefficient combustion, resulting in poorer mileage. Recognizing these symptoms early can expedite repairs and enhance the vehicle's performance. In the first troubleshooting step for diagnosing DTC P0455 or P0456, you begin by turning the vehicle to the on mode without starting the engine. This prepares the vehicle's electrical system for diagnostics. Next, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. This action resets the system states and allows you to get a fresh snapshot of the vehicle's current condition. Subsequently, select the EVAP test option from the HDS inspection menu, followed by the function test. Assessing the results from the EVAP test will help confirm whether the DTC is persistent or intermittent, guiding subsequent steps in the troubleshooting process. The second step involves examining the EVAP canister vent hose for any blockages or restrictions that may impede airflow. This hose is crucial for allowing fuel vapors to vent properly. If any obstruction is found, it must be removed to restore normal function. In cases where the hose is damaged or excessively blocked, replacement is necessary to prevent future leaks and ensure the EVAP system operates efficiently. This step is vital, since proper venting is essential for the system to maintain correct pressure and function, allowing for effective vapor capture and storage. In the third troubleshooting step, a visual inspection of the fuel tank vapor recirculation tube is performed. This tube is responsible for channeling fuel vapors back to the fuel tank, and any damage or poor connections can lead to leaks. If the tube is found to be in good condition, move on to the next step. However, if there is any sign of damage or a poor connection, the tube must be replaced to maintain the integrity of the EVAP system. Ensuring all connections are secure and the tube is intact is crucial for reliable operation and to prevent vapor leaks. In the fourth step, the EVAP canister purge valve is removed while keeping the connector and vacuum hose attached. This allows for a controlled leak check. After the removal, disconnect the vacuum hose and attach a T-fitting along with a vacuum gauge and pump. Carefully apply about 2 kilopascals or 0.6-inch Hg of vacuum and observe if the system can hold this vacuum for 1 minute. If it fails to hold vacuum, it indicates a leak at the purge valve, necessitating its replacement. This step is essential to ensure that the valve is functioning correctly, as it plays a significant role in controlling the flow of fuel vapors. In this step, the vehicle is turned to the off mode first. Disconnect the fuel vent tube from the EVAP canister and plug the canister port to isolate the system components. After ensuring the system is isolated properly, connect the vacuum pump back to the vacuum purge line. Turn the ignition to the on mode without starting the vehicle. This allows for proper testing while monitoring the FTP sensor parameters for any voltage changes. The goal is to check if there is a voltage increase of more than 0.2 volts while applying vacuum. This process helps pinpoint the failure area within the EVAP system and leads to effective repairs. The sixth step focuses on checking the operation of the EVAP canister vent shut valve. Select the EVAP test in the HDS and configure the system to actuate the vent valve. Disconnect the vent hose from the shut valve and plug it to ensure no leaks occur during testing. Apply vacuum while again monitoring the FTP sensor for voltage changes in response to the applied vacuum. If the voltage increases more than 0.2 volts, the vent shut valve is functioning as intended. If there is no significant voltage increase, it indicates a malfunction, and the vent shut valve should be replaced immediately to ensure proper operation of the EVAP system. In the seventh step, inspect the EVAP canister purge line and canister for any connection issues or damage. The purge line runs from the EVAP canister to the purge valve, and any issues here can affect the entire operation of the EVAP system. If you find these components to be damaged or improperly connected, replacement of those parts is necessary. It's critical to ensure that all lines and components associated with the canister are intact to allow correct vapor flow and pressure management. Diagnosing and rectifying any issues here is vital for the overall performance of the vehicle's emissions control system. For the eighth step, utilize the HDS to conduct another EVAP test to ensure that both the fuel fill pipe and vapor recirculation tube are functioning correctly. Carefully examine all the connections for signs of wear, corrosion, or damage. If any inconsistencies are found, the corresponding parts must be replaced to prevent leaks from occurring within the system. This ensures that fuel vapors can be properly vented back to the fuel tank and condensed for recirculation. Maintaining the integrity of these components is essential for proper fuel system operation and optimal vehicle performance. In the 9th troubleshooting step, check the flap of the shutoff valve to ensure that it is properly closed. The shutoff valve is critical for controlling vapor flow. If it is stuck open, it could permit vapor leakage, triggering DTCs like P0455 and P0456. If the flap is not closed appropriately, immediate replacement of the main flap unit is necessary to restore full functionality. Ensuring that this valve operates correctly is crucial to maintaining the EVAP system's integrity and preventing any further emissions issues. In the final troubleshooting step, closely examine the flap seal of the shutoff valve to ensure that it is intact and properly positioned. The seal must be in good condition to maintain a reliable vapor barrier. If it is damaged or missing, it could lead to significant vapor leaks, raising the risk of triggering DTCs P0455 and P0456. In this case, replacing the main flap unit will remedy the problem. This check is essential to ensure that the shutoff valve continues to perform its task effectively, keeping the EVAP system functioning as designed. After completing all troubleshooting steps and any necessary repairs, it's essential to perform a final verification. Begin by rechecking all components and connections that were assessed to ensure everything has been restored to proper working condition. Clear the DTCs using the HDS and perform a retest to monitor for the emergence of any new codes. This step is vital to confirm that the issue has been successfully resolved and to ensure that the vehicle has returned to optimal operation. Failing to verify repairs could lead to repeated issues and further frustration. So thoroughness at this stage is crucial to prevent future occurrences of DTC P0455 and P0456. Implementing a consistent preventive maintenance routine is valuable. Regular inspections of the EVAP system's components, such as the canister, purge valve, and seal, can identify problems before they escalate. Checking for fuel vapor leaks during routine services will ensure that the system remains intact and can handle fuel vapors effectively. Additionally, maintaining proper fuel levels, which is generally recommended to be less than a full tank, will prevent excessive pressure in the system that can lead to component failure. Proactive measures can significantly enhance the durability and efficiency of the EVAP system. In conclusion, understanding DTC's P0455 and P0456 is vital for maintaining the Honda CRV's performance and emission standards. Recognizing symptoms like the check engine light and fuel odors early can lead to timely diagnostic actions, minimizing long-term issues. Following the structured troubleshooting steps provided ensures that technicians can effectively identify the root causes of these DTCs, enabling efficient repairs. Commitment to ongoing preventive maintenance will help crews avoid future problems within the EVAP system. By fostering awareness and proactive measures, both vehicle longevity and environmental responsibility can be improved. Please like and subscribe to the channel. See you next time.